All right, so I want to go back over these last examples and see if we can see a pattern there, because if we can find a pattern, that's going to help us with these subsequent problems. So I have T and T prime are similar triangles, and you can see that in the drawings here, if the perimeter of T is 13 inches, find the perimeter of T prime. And let's look back at our two perimeter examples. So this example here, let's see, our K was 3, and then our P prime was 3 times our P. That's interesting. Let's look and see if it held on the other one where we did perimeter. And that's back up here. And this one we did in a different way, so it'll be really interesting to see if it worked as well. If it works, what we should be able to do, this one has a K of 3 again. Change my pen color here. Has a K of 3. And if it holds, then for K equals 3, I expect the P prime equals 3 times the big P. And the perimeter was 41.5, so I expect it to be 3 times 41.5. And let's see if that worked. 3 times 41.5. And I get 124.5. And that's exactly what my perimeter was. So that one worked. They both worked. And so what I can use now is this idea that we found a shorter method. The perimeter of the original times the multiple equals perimeter of similar. And it worked for two different shapes, so I'm pretty certain, and it is true, that it'll work for any similar shapes. Okay, I need to know what is my multiple. That's very important. I do see that I have 5 inches here and 60 meters here. So if I take 5K for some multiple for my original to my similar, so 5K equals 60, and I don't even have to worry about the units because I just know those two are in proportion. So 5K equals 60, divide by 5. That means K equals 12. So I don't have to know what X is, I don't have to know what Z is. All I have to know is that 13 inches is the perimeter of T, and then I can say perimeter of T, which we were calling a P, right? So P times K will give me P prime. That's what we figured out a minute ago. So let's try it. So P is 13, the perimeter of the original T, and then times K, which we got 12, should give us the perimeter of T prime. And 13 times 12 is 156. So 156, it is, the units on T prime are meters, so I would have to say meters equals P prime. That's a lot quicker. Let's look at the area then. So if the area of T is 20 square inches, find the area of T prime. So for T, I want to go back and look. Now we're talking about area. Let's see what we did with area. So here's perimeter, here's area. So area is 2340 inches squared, and I see, what is my K? My K is, let's put that black. My K is 6. And then I'm looking over here and I see that I did 6 times 6 to get that 36, but the 65 is my A. So it looks like I can do K squared times A to get my A prime. So let's see if that held on a triangle example. And here it is. My K for this one was 3. It was the same as the rectangles drawn above. And so if my K was 3, then I'm wondering, oh, looks like 3 times 3, so I did it again. K squared, and then times the A, which was 105. That did give me the A prime. So it looks like we have a pattern here too, but remember we're multiplying, and if we have our multiple and our multiple on each side, then we have to square our multiple for area. Okay, so that does make sense. Let's look down here and write that in. So I have the area of the original times the multiple squared equals area of similar. And I can look at it as A times K squared equals A prime. And for my actual example, my area is 20 square inches. My K was 12, so I have to square that. So I have 20 times 144. So I get 2880 equals A prime, and so I'll say A prime is 2880. And this was, remember, we had a change of units here. This one was meters. So when I do the label here, it needs to be meters squared. So R is a 3 by X rectangle. So 3 by X, and this is my R, and this will be my R prime, and it is a 5 by 8 minus X. So I'm just going to randomly put 5 and then 8 minus X. Now I don't know for sure that 3 and 5 are the two that are corresponding. So I will also want to do one more rectangle, and I'll call that one an X by 3. And then I'm going to leave that as 5 and 8 minus X for the second one so that I can have a different pair that are corresponding, because I'm not certain which one goes which way. And as long as I swap out one rectangle only, which is length and which is width, then and use the same to be similar when I do the calculations, I'll get all the possibilities for my solutions. And I do have to try it 2 different ways to make sure that I've got all the possibilities. So here, back on the first one, I want to show you from the get-go, because we haven't done this very much at all. We just were looking at perimeter and area. But if I want to look at if these two rectangles are similar, and I'm assuming the 3 and the 5 are the corresponding sides, then the first thing I want to do is find the K. So I know I have 3K equals 5. So 3 times K is going to give me the 5, and then I'll divide both sides by 3, and so my K is 5/3. And then I will use that idea on the other two, the other corresponding sides. Even though they have variables and they're going to look a little more complex, I can still do it, and it'll still work with K equals 5/3. So I want to try that out. So I'm going to have my smaller rectangle first, so it's going to be xk equals 8 minus x. So that's the general form. The smaller times the multiple equals the larger. And so when I have it that way, then I can divide. I know what the k is, so I want to plug that in. So I'll say x times 5/3 equals 8 minus x. And then that is the same thing as 5/3 x equals 8 minus x, and then I want to get the x's to the same side, and to do that I'm going to add x to both sides. And remember for the x that it has an implied coefficient or number part in front that's a 1. So I want to write that as 1. You can either use your calculator to handle your fractions. I do want to add those two, so I have 5, and I can do my fraction button 3 plus 1, and I get 2 2/3. So if I convert that into an improper fraction, it's 8/3 x. Now if you want to do that by hand, you have 5/3 plus 1, and you have to think of 1 as something over 3, so I'm just going to multiply it by 3/3 because that reduces to 1, and then I have 5/3 plus 3/3 or 8/3. Either way you can do this. And my x's on the right hand side cancel, my x's on the left hand side come to 8/3 x, and I have that set equal to 8. I'm nearly finished. I just want to multiply by the reciprocal, 3/8 on both sides, and think of it as an 8/1. And when I'm doing that, my 8's reduce, and that was handy. And on the left-hand side, everything reduces, and I end up with just a plain old 1, or 1x, and then I have x equals 3. So that's telling me that if I put a 3 in everywhere I see x, that would mean this side is a 3, and this side is an 8 minus 3, or 5, then I can see that they are indeed similar because they are squares. So I can see that that answer is a possible solution. And remember, I have one other that I need to try out, and that's using, I swapped on the first rectangle, I swapped the dimensions, and the second rectangle, I left the dimensions exactly as they were, and now I want to use the similarity going top down like this, the x to the 5. So I say kx equals 5, so that I can find out what my k is, my multiple, and then I'll divide both sides by x. And this doesn't come to a nice whole number or even a fraction, but it is 5/x. So I'm just going to leave it as that. My x is reduced. And then I'm going to write my second side, corresponding sides, as a multiple of k. So it's going to be 3k, always take the shorter or the original, 3k equals 8 minus x. And then I'm going to take that k that I found, just like I did before, take that k I found and sub it in. And so I have 3 times 5/x equals 8 minus x. And think of it as 3/1, and there's nothing I can reduce here. So I end up with 15/x equals 8 minus x. Now I want to get the x by itself, but I have an x in the denominator, and that's sometimes a problem. So what I want to do is multiply both sides by x so that I can get it up out of the denominator. So I'll multiply on the left by x, and watch carefully there with the parentheses, I'll multiply on the right by x. The x's reduce here, and I have 15 equals, this x has to distribute, and so I get 8x minus x squared. Now because I have an x squared, I know I'm going to need to factor to solve this equation, and to do that I'm going to have to set it to 0. So I will do that. I want to move the x squared to the left because that'll make it positive, and I really prefer it that way when I'm factoring. So I'll subtract 8x from both sides as well. None of these are like terms on the left, so I'm just stuck with x squared minus 8x plus 15 equals, and on the right everything cancels because they are all like terms and in fact opposites, so I'm stuck with just 0. And that's perfect. I wanted it set to 0, so now I can factor. I'm going to use the sum product method, which means you take the middle term for your sum. So I want a sum of -8, and I want a product of the first and the last. So it's going to be 1 times 15, or 15. And so what I'm looking for are numbers that multiply to give you a positive 15. And I know the choices are 1 times 15, 2 doesn't work, 3 works, 3 times 5, 4 doesn't work, and 5 works, but it's already on my list, so I'm done. And then the other thing is the signs, and I wanted them to equal a positive 15, which these do, but they have to add up. The numbers have to add up to -8. And the only way I can have that happen is if both of my numbers on each product are negative. So I'll have a negative times a negative is a positive 15. And then when I add those first two, I get -16, but I needed -8. So I'll try again, -3 plus -5, that gives me -8. And then because I have a lead coefficient or a number in front of the x squared that's a 1, I can use a shortcut, and that is to take these as my part of my factor. So I have x minus 3, x minus 5 equals 0. Now, if you haven't factored like this before, or you haven't factored in a long time, you really need to check these factors. So I have x minus 3 times x minus 5, and I want to double check by distributing this x. So it'll be x squared minus 5x, and then distribute the negative 3. So that'll be negative 3x, and then a plus 15, and then I have x squared minus 8x plus 15. And that's exactly what I started with just before I began factoring, so I know my factor pairs are correct. Now my last step in this process is to set each factor equal to 0, because I have a product of two things multiplied together to give me 0. One of the two has to be 0. There's no other way to get a 0 as a product. So I have x minus 3 equals 0 and x minus 5 equals 0. That gives me two simple equations. Add 3 to both sides on this one, add 5 to both sides on this one, and I end up with x could be 3 or 5. So I already knew about the 3 from the previous trial, but now I also know about the 5. So my two possibilities for x are 3 and 5. Let's look at another one. This one is a 2, this is my r, and my r prime, and so this is a 2 by x rectangle, and r prime is a 6 by x plus 1 rectangle. And we want to know what values of x are going to make the two similar. So remember, I can draw how they're explained for the first pair, but then I have to swap. I'm going to swap the r and have it be an x by 2 in my second trial. And that'll be r prime, and this is going to give me x plus 1 and 6. Okay, so I have two sets that I have to work out. And this first one, I'm looking at the 2 to the 6, so 2k equals 6, divide by 2, k equals 3. Perfect, I love 3, it's a great number. Now for my x parts, it's going to be xk equals x plus 1. So you take this one, everything on the first triangle, you're going to multiply it by a k to get what's on the rectangle. Everything on the first rectangle, you're going to multiply by k to get what's on the second rectangle. So for the corresponding side, so we have to keep that in mind. X times k equals x plus 1, but I know what k is, so I'm going to plop that in there, and I'll have 3x. I just changed the order of the two, but it's still equivalent to x times 3 equals x plus 1. Solve for x, so I want to subtract the x from both sides. So I get 2x equals 1, and then I want to still get that x alone, so I'm going to divide both sides by 2. And so I have x equals 1/2. That is one solution. Now I need to check what my other possibilities are. So down here I have them drawn where I swapped the dimensions on the first rectangle, and now I'm looking at x and 6 as the corresponding sides. So kx equals 6. Divide both sides by x because I want to know what k is, and my k is 6 over x. Now for my second set of corresponding sides, 2k equals x plus 1. And so I want to put in that k because I know it. So 2 times 6 over x equals x plus 1. And this is going to give me a similar polynomial like I had for the last problem, which is fine. We know how to handle it now. Multiply both sides by x. These cancel, and I have 12 equals x squared plus x. So I'll just subtract the 12 from both sides. and I end up with 0. It doesn't matter what side I get it on, but I have a 0 there. And now, when I have a 0, that's very important, now I can use the sum product method to factor. So my sum is going to be the lead coefficient, or the coefficient of the middle term, and that's a positive 1, and my product is going to be the lead coefficient and the constant, so 1 times negative 12, which comes to a negative 12. So I'm thinking of all the multiples that give me 12. I know there's 1 times 12, there's 2 times 6, and there's 3 times 4. And then I would go to 4 next, but it's already on my list, so I know I have all the multiples that'll give me 12. So problem, I need to have a negative 12, and for the sum, I have to have a positive 1. So if I want to get a positive for my sum, then my smaller number has to be negative. And so then I'm adding those two, 12 plus a negative 1, so I'll get 11. That's not my positive 1. 6 plus a negative 2, that gives me positive 4. Still not my positive 1, but I think I'm going to get it soon. 4 plus a negative 3, that gives me a positive 1. So there's my pair. And remember, because I have a 1 for my lead coefficient, I'll just write that. If the lead coefficient and that means it's on the x squared term is 1, use the shortcut. Okay, and my shortcut is to say x minus 3, x plus 4. And then once I have it in factored form, which it is now, I can double check by multiplying out, and I really recommend that you do that. And then I can set each factor to 0. So plus 3 plus 3. So I have x equals 3. And then minus 4 minus 4. Make sure you watch those signs so that you're actually undoing. And then I have x equals negative 4. So I have two possibilities for this arrangement, and it is 3 and negative 4. But remember, I can't have a negative length. I can't say my width is a negative 4. That just won't work. So I have to ignore that solution that I came up with, and I can only use the negative 3, or the positive 3, I'm sorry, which is going to be paired with that 1/2 that we already got. So I have two possible solutions for this set of rectangles. And as you can see, I had to do it as two trials. There was no way for me to get it just using one arrangement or the other.